Okay, so this video is going to be about inheritance and some of the more complicated features of classes. So you'll notice here I have written an animal class that is relatively basic. It has some setters, it has some getters, it has three variables. Has legs, which tells me whether or not an animal has legs. Sound, which indicates the sound that the animal makes when exposed to a two-string method. And then type, which is in general just going to be a string with the animal name, or not the animal name, the animal category, type of animal. And this isn't strictly necessary, but we'll be using it a little later, just to show a couple different ways we can interact with these classes. So to start out, you'll notice that I've indicated that these variables are protected. And protected indicates that this variable is accessible by the class animal, or by any objects of the animal class, and by any objects of its subclasses. And we'll look at subclasses in a minute, but these are classes that extend animal, or use the keyword extends. If these were private, they would just be available to the animal class. So let's go through and let's say, okay, well, public animal, it's just a basic constructor. I'm just setting some basic variables. And my basic two-string method is just a little rustle. So a standard animal will just rustle, maybe through the leaves, uh, you know, great rustling sound. But just maybe like this. So that would be what an animal normally does. Relatively useless. I mean, I could probably make it more interesting. But you know what? I think I'm going to use this as a basis for how my other animal types are going to act. So what I'm going to do is I'm going to create a class called Porcupine, which I've already done. And you'll notice it's really basic. It has some string name, it's private. It has a constructor which takes in that name. Then it has this word super. And then it has the name being set to name. And the reason is because, porcupines are pets, and one might give them a name. If it's another type of animal, maybe it won't have a name because we won't understand that animal's speech and naming system, cultural differences. So in this case, this is just a name that someone might give the porcupine. And we'll see how that's used in a minute. Now this class has this constructor, and you'll notice that I use this word extends animal, which means it's a type of animal. It actually inherits all of the properties of the animal class. It has all the methods, it has all the public variables, it has all the protected variables. And you'll notice that it might have a toString, it might have a set type, and we'll see how this is used in a minute. But it also has the constructor of animal, and we're going to call that using super. Super indicates that we're looking at the superclass, and the superclass is the one that we are extending. And so we'll go up a level and we'll use that constructor, and so we'll change the sound that the animal has to a rustling meep sound. And then we'll go and say that it is of type porcupine, and that it is definitely an animal with legs. We'll go through and then we'll say, okay, well, instead of the standard animal toString, we're going to override that using the porcupine toString. So it has the same exact signature, and we're just going to override it, have the same signature in a lower class, which will take precedence over the standard animal toString class. Let's look at how this is done with a dolphin. So dolphin also extends animal. It is a type of animal. It has all of the methods available to it that animal provides, as well as all of the protected variables. And so you'll see I also added one called speed because, while dolphins may not have names, they're definitely fast. You'll notice I've given it its own splash, squee sound, and then also indicated that it's a dolphin. Again, that's not so necessary, but I have it there just for a demo later. And then it doesn't have legs. It's false. Its set legs is false. I also set the speed here. You don't have to have anything else. But in this case, you might say, okay, well, can I implement other methods? Sure you can. And they are only available to the dolphin, but not the animal, because they're declared in dolphin, not animal. Animal is like a generic umbrella for things an animal might do, but that things that every animal should be able to do. Whereas dolphin is like more specific animal and should have classes or methods that more specific animals would have. For instance, dolphin. So slow down. So I have this method slow down. I also am again overriding the toString method. So overriding indicates that I have the same signature, but I'm using it in a subclass and it takes precedence over the superclass version. So in this version of the toString method, I am increasing the speed of the dolphin, and I'm returning the sound and an indication of my new speed. Notice I don't have any getter method for the speed. Okay, and now I'm going to use these. So I'm going to go to Animal Pen, and I'm going to say, okay, well, I'm going to make an array of animals. How can I use this property of inheritance, this property of, and this subclass superclass relationship, to use this array to store a bunch of different animals? Well, certainly I'm allowed to do that using this thing called an is-a relationship. And that just means that, for instance, a dolphin is an animal. And same thing with a porcupine. Is an animal. And as a result, that means that because they have the properties of an animal, well, I could store them in an array of animals. So for instance, animal 0 could be a new dolphin. And what do dolphins get? They get nothing in their constructor, as you can see. And this isn't throwing me an error. I could also make some random dolphin here. So far in my array I have a dolphin. Outside of my array I have a dolphin. They use the same constructor, all of that. One's just stored in a dolphin variable and one is stored in an animal variable. And an animal array variable. I could also say animal A equals new dolphin. But I can't say dolphin D1 equals new animal of A, B, false. That doesn't work. And why? Well, because I can't convert from animal to dolphin. Dolphin is too specific. Animal is generic. It doesn't have the things like the speed variable or the output, the toString method, the slower method that dolphin provides. So that is not allowed. Because an animal is not necessarily dolphin, but all dolphins have the property of extending animal, and therefore they are animals. Couldn't I do this with porcupine? Of course. And porcupines do have a requirement in their constructor, and it is because of the porcupine. And if for those of you who are Spanish students. And now I'm going to go through this array and print out my values. So how would I do that? Well, let's use a for each. For an animal, oh, oops, not animal A. Let's cross that out. For animal A in animals, for every animal in animals, I'm going to print out a.toString. And let's see what happens here. And I get a null pointer exception because I have not finished my array. I have not filled it all out. So what I can say, if if not is null, or not null, or if a, let's see if that works. Yeah, so if A is not null, then we can print out A. And so in this case, I have two objects, two animals. Maybe I'll add a third animal, and this time I'll actually make an animal. And I'll give it the sound posh. And donkeys have legs. Okay, and I'll run this. And oops, let's say 2. And you'll see that now I have 3 animals printing out. Splash, squeeze, so that's my dolphin coming out first, my porcupine coming out second, and my rustling donkey coming out third. But it's not necessarily really a donkey, it just has the type donkey. One way I can do this is I can say, well, certainly each one is calling its own toString method. One thing I can do is I can also say, okay, well, what is the animal I'm looking at now? What type is it? So animal, so let's say A, the animal I'm currently on, is it an instance of dolphin? So what this does is it returns true if the animal is a dolphin, and it returns false if it's not a dolphin. So let's run it. So we get true for the first object, false for the second object, and false for the third object. They're not dolphins. But if I say, if are they all instances of animals? Well, certainly they are, because they all extend animal. They're all of the type animal, but they may also be of the type something else. If you don't want to use the instance of, you would have to use the property I included of type, which is just a variable. I might say, and a.getType equals donkey, which I haven't created a donkey class. I've just put it into my generic animal, and it only prints out the third animal, animals 2, because it is the only one that has a type of donkey, but it prints false because it is not an instance of dolphin. And so you can see that we can actually do a lot with this. I can have a whole zoo of animals and then use their own toString methods and then call special methods here. For instance, I might say if A is not null and A instance of dolphin, maybe I'll print out A, and then I will call the special method provided by Dolphin and make it go slower. And I have to cast it. So this is a special thing where if you know what type you have, you do have to cast it first to that type, and then call the method on it that is owned by it, unless it's owned by animal itself. So now it says I'm going at speed 6, but first maybe I will go slower, and it'll definitely invoke that method. So again, what I've done here is I've changed from the explicit type animal to the explicit type dolphin, which indicates that I can use any of the methods in Dolphin. Otherwise, I'm relegated to using methods like toString, which exist for all animals. But you notice I know to change to Dolphin because A is an instance of Dolphin based on the instance of keyword. Okay, that's enough for now. I'll talk about the use of inheritance with interfaces shortly.